Hello, hello. Good morning, everyone. Thank you for the warm welcome. Now, I couldn't resist. I played around with AI a little bit. I remember last year, I think David Vogel gave a great talk about generative AI with Robot Framework. And for me, this was like a wake-up call, like now it's the time to start building solutions with AI for Robot Framework. Because if we don't do it, nobody else will do it. So topic of the day is experiments with self-healing using AI. I created a funny little tool. You can find it here with the QR code. I will also show it later at the end. It's still very experimental, but let's see if you find value in that one. Few words about me. I'm Mani Kasiriha. I'm from Germany. I work there as a QA engineer at DB Schenker and a board member of the Robot Framework Foundation since 2022. Family man, like to do some music, play some games. And I can for sure say I'm not an AI expert. Yeah, so I'm the same as everyone. I'm loving QA, loving Robot Framework, but not an AI expert. I just wanted to explore stuff. But coming to the topic, self-healing tests. Does anyone have an idea what that means? Maybe raise a hand. Do you have a rough idea what self-healing means? Okay, so I see like maybe a quarter of hands raised. So let me explain it with an example. So I'm talking here about self-healing tests on the UI or here in the web browser. So that's a very simple test case here. It just enters some to-dos in a to-do application. So the first test case will just enter 2 to-dos and then check the number of items. Now, I set it to slow motion, so it's kind of slow. And the second test case enters a to-do and then marks it as done. And again, checks the number of items. Very simple, very straightforward. Now, between us, we all know it takes very little to break such a test case, doesn't it? A new release, some new locators or some new div elements or elements in the user interface. So if I just mess up my test case a little bit, so I mess around a bit with the locators. So I'm messing around with the input field, with the marking field of the to-do. If I run it now, well, what happens? I guess you know the answer. Yes, exactly. So it will still open the web browser, but on the first occasion, it tries to enter the to-do. Failure. I mean, we don't have that in reality, but so, and then, of course, our QA engineer work starts. We need to open some log files, check the error messages, what's wrong, and then open the web browser, the dev tools, check the new locator, and so on. But I was wondering, what if would be different? What if I could add something small to my test suite? For example, a library or a listener with some strange arguments, not important right now. And if I would run the same test case with that small thing in there, and what would maybe happen is it would first hesitate to enter the to-do, but then it would magically proceed somehow. And the first test case would pass successfully. And also for the second test case, it would take a moment, but then it would just proceed as in the past version. It would enter the to-do and mark it as done. Even though the locators will still kind of different in my suite. So that was the idea I had in mind when I created the self-healing solution. I was wondering, self-healing tests, why would anybody want that? Well, I realized sometimes we spend a lot of time on simple, basic tasks, like fixing a locator, add some synchronization step, or handling some unexpected pop-up. And then we need to rerun the stuff again locally, push the code, rerun in a pipeline. So wouldn't it be nicer if such things are just fixed during runtime? And you might also wonder, is it clever to use AI for it? Not sure in hindsight, but I just wanted to play around with it. So that's just what I got. Before I started my little project, I set up some rules for myself. If I wanted to do a self-healing solution, I wanted to do minimal test code changes. So I did not want to replace all of my selectors with variables or stuff or put them in a database. I just wanted to inject something small into my test suite. Then my approach should be library agnostic. That means it should be able to heal things like browser library, but there should also be the possibility to do it for Selenium library or Appium. Yeah? At the moment, my tool just does browser and a bit of Appium. Then for the LLM usage, I also wanted to do something different. I see that a lot of AI solutions are very much focused on OpenAI, which is a great service. I love it. But a lot of companies are not allowed to use it because of some regulations. So what I wanted to do, I wanted to focus on small, open, and self-hosted large language models like Llama, like DeepSeek, like Phi. Yeah, those small ones that you can just deploy locally also on your home machine and then interact with. And the last thing, I wanted to be flexible on the model, because we know now every week a new model is coming out, which is again better than the previous one. So I didn't want to code something for one model, but wanted to be flexible that when the next model arrives, I could just switch to that one and use it. And with those rules, let's go to the architecture and look a bit what this tool is actually doing. It all started back then with Robot Framework 7.1 mid of last year in August. I think Pekka gave an open space and he introduced the listener changes to Robot Framework 7.1. So what was then possible with the listener changes, it was possible to hook into the test execution when a keyword is ending, and then you could change the result status for the first time. That means during the test execution, you could override the result status of a keyword. And what Pekka showed back then was, if the result status is passed and something bad happened, then the result status is fail. For example, if the execution time was too long or something. But I was wondering, what if we turn that around? So what if we say the result status was fail and something good happened, and then the result status is pass? Could we maybe use that approach to inject some self-healing? And with that approach, I had this simple architecture in mind. So it all starts with the end keyword, or here with the end library keyword. So this end library keyword function is called by a listener when a library keyword is ending. So a keyword from the browser library, from Selenium, from Appium. So it's for those low-level keywords. And what I'm doing there is, if the keyword is ending, I'm checking what's the status. If it's passed, then nothing to do, it will just proceed. However, if the status is failed, and if the keyword, for example, belongs to browser and the root cause is a broken locator, then I will try to get a fixed locator. And now let's look at some code. We are early in the morning, you had a coffee, so we can deal with some code. So that's from the end library keyword here. And you see in the first highlighted row, we check, is the result status failed? And is the result owner the browser library? Yeah, so this is like the entry point. Only then the self-healing becomes active. And then I'm getting the instance of the browser library because I need to do some browser stuff in my test later. And I'm initializing an object from the browser healer. So this is a class which can do something like fix a locator. Then I'm checking next, is the locator broken? Yeah, this is the next highlighted row. And if it's broken, well, then I will try to get a fixed locator. And if I got the fixed locator, I will try to rerun the fixed locator. So this is just the code from the listener's point of view. Very straightforward, I would say. But of course, that doesn't get us a fixed locator yet. We need to do a bit more to do that. And this is where the large language model comes into play. So what we're doing next is we need to collect some information, like what was the failed locator, what was the error message, what was the keyword we executed, and what is the page source. So the whole DOM tree, the whole HTML code, what is that? And need to hand it over to a large language model and hopefully let it find the fixed locator for us. Now for the large language model, I'm using Ollama as a tool to deploy large language models. It's very easy and straightforward to install on Windows, Linux, Mac OS, and it has this command line client. So you can just say Ollama run and then Ollama 3.1 model, and then it will load the model into memory, and you can send a prompt to the model, like what is robot framework, and it will reply. You can also change models easily. So I can also say Ollama run and then a Phi 3 model. And again, it will take a moment to load this model into memory. And then I have my local Phi 3 model that I can send a prompt to. Yeah, so it's pretty easy to just run and deploy models locally on your machine. I can say I have a very weak machine at home, just with an AMD graphics card, so no huge expensive NVIDIA card, and it runs quite well there. But of course, command line client is not so interesting for us. We want to write some Python stuff. So they also offer a Python API that you can use to interact with the model. So here you can see some code example where I send the same prompt to the model via Python. But in general, it's just a web service. You can also run it via curl or requests library. And it's fully compatible with OpenAI. So you could also use the OpenAI library here. So this is how I interact with the large language model in my listener. Then, of course, I need to collect the information first. So I'm getting all the data like the failed locator, the error message, the keyword. I'm getting that from the data and the result objects from the listener. So they all contain that information from the current keyword. The only tricky thing is the source code, so the DOM tree of the web page. For that, I need to call a keyword of the browser library. Here, in this case, the get page source. There are similar keywords also for Selenium or Appium. Yeah, so this could be implemented differently also for Selenium and Appium. And finally, I'm putting this information together in a dictionary that you can see here. I add it to a list of messages, and this is what I will send then to the large language model. Yeah, this is all the information it needs. And if we look at the current example, the to-do app, so this is the kind of information I would send for the failed input field here. So the error message is just the robot framework error message waiting for locator to do. The failed locator is the broken locator I was currently using, just .to do. And the keyword is, for example, fill text when I was entering the text here. And the page source, yeah, a lot of HTML. Won't show it here completely. But you might wonder, so how does the large language model know what to do exactly? I'm just throwing over some stuff. I mean, I need to give it some input. Hey, what to do with that stuff? And this is where the system prompt is important. So here you see the example of the system prompt I was using. You don't need to read through it, yeah. But the system prompt tells the large language model what is its goal and what it should do. And I would like to highlight just a few key points, yeah. So first, I'm starting the system prompt with the goal or the mission of the model here. So I'm telling it, hey, you're an XPath or CSS selector cell filling tool. You will analyze the page source, error message, and find the best alternative fixed locator for the failed locator. That's the purpose, the goal. But that's not enough to solve it. I'm trying to give some more rules or hints. So I'm saying, hey, for keywords like a fill text, please return me the input elements. Don't return me buttons or links or something. Just return me the input elements, because this is where I can fill text into. So I'm trying to give it some more information how to solve that problem. And then the last one is how it should respond to me. So I'm telling it what should be the output format. And I'm telling it here, hey, please respond in the following JSON schema, a dictionary with fixed locator and the locator name. Is anyone good with JSON here? Can you tell me, is this a valid JSON that I'm putting in here? No, it's not. So I messed up, and I also realized later. So it's a funny thing when you work with large language models. They won't tell you you make a mistake. You will only realize later when the responses are weird that you made a mistake in the first place. And I can also say, do not trust a large language model to respond in the format that you ask it for. Yeah, even though if you tell it respond in JSON, maybe there are cases where it will not respond in valid JSON. Make sure to have some code around it which will deal with that. But with that, yeah, we got hopefully our healed locator, and then we could rerun the same keyword again with the healed locator. I'm not showing that now. I'm just using the built-in library with the run keyword to just rerun again. So with that, yeah, we can heal locators, more or less. So I just put an example here from a car insurance calculator. We will watch a video next. But just to show you how I messed up the locators. So on the left-hand side, you can see the original, the working locators. So those are the good ones. On the right-hand side, you can see what I messed up. For example, instead of make, I used vehicle brand. Instead of date of manufacturer, I used creation date. Just to see how different my locators now are. And let's have a quick look at how the execution looks like when I run that kind of test. So, Tricentis on a RoboCon conference, also something you don't see every day. It's just a sample app from them. So you can see here, the test case will run. It will enter the fields one after the other. And in the terminal, you can see some messages. We will enlarge them later. So the listener will give us some response like, hey, I'm trying to enter that field, but I failed. And now I'm retrying with a fixed locator. Yeah, so this is what we are getting here in the terminal. And now the tool also generates a report with the fixed locators. So we will get some information like what was fixed, in what file and which line. I'm just showing like a part of the report here. And what you can see, the large language model is very creative with the locators, isn't it? So first locator is a fixed locator using the ID make, but then in the next lines it's using the label and going like one level up to the parent and then using the select element, and then it's using the name attribute with the list price. So it's very creative and hard to guess how the model will create the locators. This is on one hand nice, but on the other hand, some locators are just a bit weird. And overall, soon I realized that my prototype had plenty of problems. Yeah? Also, the emojis have some problems to realize they don't transfer well between Windows versions. So first problem I had, Shadow DOM elements. Who knows Shadow DOM elements here? Few hands. They're always fun, right? Dealing with Shadow DOM. So I realized too late that those Shadow DOM elements are not returned by the get page source. So I was expecting to get the full DOM tree, but then when I was running my example on a real application, I realized, damn, I'm missing a lot of elements, needed to find a way to get them. Then the next problem, hallucination. And this is a typical large language model problem. Some proposed locators did not make sense or were totally made up, and some decisions did not make sense to me. So this is also something I had to deal with. And my last biggest enemy was the context length. So the context length is like the attention span of a large language model, how much information of the prompt it can see or understand. So for example, now it's early, your attention span is like very large, you can get a lot of information. Maybe on Friday on the after party, your attention span is a bit lower, I don't know. And it's the same with the large language model. If the attention span is too small, and you give it a full DOM tree, it might start reading the DOM tree, but when it reaches the end, it might have forgotten the beginning. Yeah, so it only gets a part of the information. However, if the context length is, you set it too high, then what might happen is that the responses are very slow of the large language model, and then it eats up too many resources on your machine. So those were some problems I had to deal with. This is an example of the Shadow DOM elements. So if you see something like that in your DOM tree, congratulations, you have a shadow DOM element. To solve that, I needed to write some JavaScript code, which is very bad for me because I'm very bad at writing JavaScript. But it was possible to execute some JavaScript code inside the browser instance. So I could run it with the evaluate JavaScript keyword. And I was able, with that approach, to retrieve the full DOM tree and construct it again and get it back from there. So this was doable. You can check out the source code in my repo. For the context length, I needed to do a lot of trimming on the DOM tree. So when you look at the DOM tree of an application, there's a lot of unneeded stuff that you can maybe get rid of, like script elements, SVGs, footer, header, and also not all of the attributes are really important. So I just trimmed down the DOM tree a lot to make it sure it fits into the context length. So this helped me to reduce a lot of things. But still, I wasn't happy with the suggested locators. Yeah, so as I mentioned, the locators were kind of random. Sometimes they were not found at all. So I also implemented a CSS and XPath generator into my tool, which will try to create unique CSS and XPath for every element. It will try to create them unique and short using the ID, name, placeholder, but it can also check the text content. It will also check for siblings and the parent elements if that helps to create a unique locator. So what I did in the end, I turned the problem around. So I'm not giving the full DOM tree anymore to the large language model, but instead I'm just creating a list of locator proposals and sending that to the large language model and say, hey, please find the most likely locator from that. But there was one more piece missing, and that was additional information or additional context. So what I did as well was, for every locator proposal, I tried to collect more information, like what is the tag of the element? What is the text? Is it clickable? What's the sibling, the previous sibling, the next sibling? So just that we enrich each locator proposal with more information, because that also makes it easier for the large language model to choose. And I'm also collecting this information for past runs. So it's also possible for successful runs to get this additional information and write it into a database. And with that, the architecture is now a bit different. So instead of just relying on large language models, I'm having two options to get the fixed locators, either via the large language model or via the CSS XPath generator. Then I'm adding those additional information to each locator proposal. And then I'm putting this information all together and again asking the LLM, please give me a proper locator for the failed one. Yeah. So potentially I would do 2 LLM calls, but if I use the CSS generator, only 1 LLM call. And with that, the quality of the proposed fixes was much better with this enriched information and the CSS generator. So I need to come to an end. So just a short summary. So I created a small listener library. Feel free to check it out. It's kind of an experiment. Like Mika said, be open-minded. Yeah, I'm sure it will improve over time. It has some interesting features. It has some basic self-healing for browser, a little bit of Appium, which is really a pain in the neck to self-heal, I have to say. So I'm looking forward to the next talk. Just give it a try. Can find the source code here. And with that, I would close with a little call for action. So if you're interested in this AI topic, join the AI team. So you can find us on the Slack channel in the channel AI Robot. We will try to put a work group together focusing on building AI solutions for Robot Framework. Just have a little exchange, talk, maybe some knowledge exchange there. We will have the first meeting next week, Friday, 21st of February, between 3 and 4. So it would be great to be there. Looking forward to the first meeting. As I have a few seconds, I just want to mention, while investigating my topic, I saw there was a master's thesis about self-healing with Robot Framework in 2024. Yeah. So I was very impressed that this kind of scientific research is done here in Helsinki. So pretty great stuff. I tried to find the author, maybe to also speak here, but I couldn't find him or her on short notice. So I recommend to check that out if you have the time. And with that, I would end my talk. So thanks a lot. Looking forward to your questions and hope to see you at the work group. So thank you.
Excellent talk, Mani. Questions? Who wants to? Yeah. Sorry. I knew this.
Hello. Hi.
Hey.
I'm Peter. Quick question. How do you know when you have a final report and you have like 200 or 400 test cases run there, that which one of those were fixed?
At the moment, I don't mark them, but that's a good point. I need to find a way either add a tag to them or maybe add a special message to them that something was healed. Because you're totally right. At the moment, they show up as healed. At the moment, we have the original failed step in the log and also the self-healing step. So you can see it when looking at the log. But on the report level, we would need to add something, maybe a tag or something like that. So good point. This is something still need to be done. Yeah.
Related to that, is the test updated?
No, this is not updated yet. The reason is, first, I wanted to see how good is self-healing actually. And as you mentioned, when you do something with Copilot, you also directly take the code and put it there. You maybe need to adjust it. So I thought at first, it's better to have the report with the healed locators so that you can just copy and paste things into your code. And maybe the automated robot test suite healing maybe as a next feature. So at the moment, it's more of a smart recovery with an additional report at the end. Yeah,
that's good. If you can pass it back there, there's one.
So how is the repeatability? So if you run the same broken test case multiple times in a row, will the end result change much?
So with the CSS generator, when the locators are generated by my tool, then the suggested locators are stable. So it's every time the same locator is suggested. If you use the large language model approach, well, then the locator is kind of different every time it's suggested. And most of the time, it still proposes a fixed locator. So the overall result is good. It finds the right element. But when using the large language model, it's not in a way stable. The suggestions are always different. And that's why I also didn't like it. I wanted to do like the generated CSS selectors instead.
And will you try a new loop if the LLM model fails at self-healing, or will it just then proceed with fail?
At the moment, I will give it like 3 tries to give a suggested fix. But the problem is, if the model thinks it found a right fixed locator, and this is from a different element, then you are like in a world of pain, because then it might take a wrong turn and do something completely weird. So I need to define one strict end criteria when the LLM will stop self-healing. And this is a thing I still need to figure out. Yeah. Hope.
More questions? Yeah.
Do you have any idea how much of your elements are healed by your CSS generator and how many by the LLM itself?
Yeah, so I can switch it on and off, the CSS generator. If I switch it on, everything will be generated by the CSS generator. So this is like an argument I can pass to the library. If I switch it on, everything is generated by it. So this is how I can distinguish. Yeah.
Any more questions? There's one, and let's take these two. Just pass it here. Yeah. That's safer.
Question is working.
Now it's on.
Now? Okay.
Yeah.
My question, is it going to make my test execution a little bit slower?
Yeah. Yes, definitely. So in the videos, of course, I tricked a bit. I played them relatively fast. But depending on the large language model you're using, the response will take a moment. If you have a weak PC, it might take a long moment. So it will definitely reduce the execution speed for failed locators. If they are passed, if this step is passed, this listener will not affect it much. But if it's failed, you're totally right. It will not be in real time. It will take a moment to heal, definitely. Yeah.
All right, let's take the final question from there.
Hello. Yeah. Not a question, but you showed the master's degrees thesis at the last slide. Actually, Paavo is my head of our automation team.
Oh, no way.
So yeah, if you have any questions or you want to get in contact with him, you can just find me and I can give you the information.
Oh, that's great. Because I tried to find him on the internet and yeah, thank you.
And I recommend everybody to read the master's degree thesis. It's great.
And why Paavo isn't
online.
here?
Actually, Paavo wanted to be here, but he is on vacation. So he's out of office. So I'm kind of here.
Let's get you a Joker sticker also. That's good, linking up Paavo and Mani. Thank you, Mani.
Thank you.
Here's your